We've done a lot of work with two equations and two unknowns, and where each equation in two variables represents a line, so you're just trying the intersection of a line. But what happens when you start having three variables in a linear equation? So for example, let's say I had x plus 4y plus z is equal to, I don't know, let's say it's equal to 8. So how do we think about this? How do we think about it visually, first of all? Let's see if I can graph this. So I like to draw my x and y axes in the traditional manner, and then have the z axis popping in and out. You'll see what I mean. So that's my y axis. That is my x axis. And on my z axis, I can't make it, since this is a two-dimensional format, it's hard to do it, but I'll draw it with a little perspective. The z-axis, this is the back. You can imagine this is behind your screen. And now I'm going in front of our screen, or above our screen, depending on how you're viewing it. So that's the z-axis. That is the x-axis, and that is the y-axis. So you can almost view this as a traditional x and y, and now z tells us how, if this was your piece of paper, how much above the piece of paper we are, or how much behind the piece of paper we are. So now we're now dealing in three dimensions. And now something to think about, and I'll answer it to you for you in about 2 seconds, is what does this represent in 3 dimensions? Does it represent a line in 3 dimensions, or something else? Well, it turns out that it actually represents something else. It represents a surface. It represents, and since the coefficients are linear and not the coefficients, since the variables are linear, it represents a plane. It would represent this big curvy surface if we had squares in here and all of that, but we're dealing with three-dimensional linear equations, so this is just going to be a plane. And let's see if we can visualize it. The easiest way to draw this is to figure out the various intercepts, the various axis intercepts. So the x-intercept, the y-intercept, and now the z-intercept. So what is the x? Well, let's do the z-intercept first. The z-intercept is when x is equal to 0, y is equal to 0. What is z? So if this is 0, this is 0, z is equal to 8. So that's this point right here. Z is equal to 8. Now what is the y-intercept? That's when x is 0, and z is 0. So if this is 0, this is 0, what's y? 4y is equal to 8, so y would be equal to 2. That would be right here. Y is that's 0, 2, 0. Right? 0, 2, and then no z, 0 right there. And then finally, let's figure out the x-intercept. So y is 0 and z is 0. So if this is 0 and this is 0, x is going to be equal to 8. So that is this right here. Now, we could draw a line connecting these, and this wouldn't be necessarily the graph, but it'll help you visualize the graph of the plane represented by this three-variable linear equation. Let me do it in a really light color, just so it doesn't. So there. And in most classes, your teacher will often view this as the graph, but I want to, you could kind of view this. This will be, and let me see if I can draw a little bit of, just to, hit the point home. This is a surface. So if that's our surface, so it would be the plane that connects these 3 points. And these lines right here, you can kind of view them as where this plane is intersecting with this, not quadrant, octant, right? Because we have 4 cubic areas in the back, you can kind of say behind the page, and then we have 4 quadrants above the page. You can view it that way. And so this is kind of the intersection of this plane with this top right up octant. Hopefully that doesn't confuse you. But it's important to keep in mind that the plane just keeps going. The plane just keeps going. And a plane in 3 dimensions is defined by 3 points, so that's why it's useful to draw those 3. But this plane just keeps going in each direction. And this is the best that we humans can do at graphing a 3-variable linear equation on a piece of paper. I mean, it's a lot easier if you could do it on a computer, and then you could rotate it, you could see it a lot better. So what does it mean if you have, let's say you had 2 equations like this. Let's say you had this equation, and then you had a, let's say another equation. Let's say you had, I don't know, x plus y plus 3z is equal to, I don't know, is equal to 3. So that graph, let's see, the x-intercept would be here. It's going to be really messy now. The x-intercept is there at 3. The y-intercept is at 3. The y-intercept is at 3. And then the z-intercept, 3z is equal to 3, so the z-intercept is going to be 1. So if I were to attempt to draw that plane, at least in this octant that I'm participating in, and this is where it gets messy, that plane would look like that. And it goes off in every direction. And now, if I had these two equations, and I have 3 unknowns, what is the intersection of these two equations? Or what variables satisfy these two equations? So I hope you can visualize it. The intersection between this green plane, which represents by this, and our original plane up here, is going to be a line. And that line is going to look something like this. They're going to intersect right there. There's going to be a line that is in common between this green plane and between this blue equation or that blue plane. And that might be really hard to visualize, so don't worry about it too much if you find that confusing. But this is the best that I can do. So as we can see, if we have 2 equations and 3 unknowns, and the solution is a line. And a line has an infinite number of points on it, so it still doesn't help us much. But it turns out if we were to throw in a third plane in there, or a third equation, and I don't know, maybe it's, minus x minus y minus z is equal to 0. And, that's going to be something else. It's going to be harder to draw. But now, this plane is going to intersect this line, assuming that it's not parallel to one of the other 2 planes, or it's not equal to one of the other 2 planes. This plane is going to intersect the line that is the intersection of this and this plane exactly 1 point. So that's just a long-winded way of saying that 3 planes that aren't the same plane and that aren't parallel to each other will intersect in exactly 1 point. Or another way to put it if you want to solve for a unique x, y, and z, your constraints have to be 3 variables in 3 unknowns. 3 equations with 3 unknowns. So let's do one of them. Let's see. Image. Actually, we're already pushing 8 minutes. This video will be about visualizing, and then the next video I'm going to actually solve one. I'll see you in the next video.